So I guess, first of all, thanks for attending this talk. Today we're going to talk about a really gentle introduction on EDR bypasses. Hopefully we're going to benefit those who never done this, but also hopefully a few tricks for those who have done it and doing red team engagement. So first of all, some brief introduction. My name is Riccardo. I work as a principal security consultant at WithSecure. So what I'm doing is like regulated red teams, purple team, and stuff like that. And also with us, we also have Devid.
Thank you. Thank you guys for being here. I'm Devid. I work as a senior offensive security consultant. Mostly I do offensive security operation, red team activities, purple teaming, and adversary simulation.
All right, guys. Maybe this is not something that you're, particularly new, but all the marketing stuff related to the EDR word in general is, without being too polite, is full of crap. Not gonna lie. All the evaluation, everyone says, "Oh, I have 100% coverage," even though all the breaches still happen like pretty much regularly. So hopefully throughout the rest of the presentation, we're going to give you like some advices, and you will be able to navigate that world of marketing a bit better and being able to determine, that these guys are just lying to us, because 100% doesn't mean anything. So first of all, for those who are new to this, just giving a really brief, hopefully it's going to be a brief introduction to what EDRs are. I mean, I'm not going to spend time talking about the acronym, whatever, but the main purpose of this system is to collect telemetry from endpoints, right? What does that telemetry do? Some part on the endpoint, some part on the cloud, that will get aggregated and that will generate alerts for analysts to triage. Usually those systems also provide some ways to respond to attacks, so things like isolating hosts, killing processes, and stuff like that. Now, the biggest problem with what we see when people are describing EDR bypasses in general, in like blog posts, courses, and things like that, is that most of the people think that the reality is what's on the left, like an isolated black box on its own. Well, the reality of big enterprises network is much more complex. So the EDR is just one piece of the big puzzle. So you see that you have firewall, IDS, and stuff like that. Everything working together in people, processes, and technologies. And ultimately, you have a human triaging these alerts that all these systems will eventually do. So why am I mentioning this now? Is because despite this presentation is going to focus only on the EDR aspect, right? It doesn't necessarily mean that's the only thing that's going to, come into play when dealing with red team operations. So what we see on courses and like blog posts, research and stuff like that is that, you bypass the EDR, then you're good. And not really, because there's a lot of other things that can go wrong. So what it means is that, you bypass the EDR, fine. A lot of other things can go wrong. This is also to say that considering that we have a human analyst that at the end of the day is going to triage most of those alerts, right? And they're the one that have to determine, this is a false positive or not, and I have to escalate it to like layer 2, whatever your SOC structure might be. It means that even if you do if you do trigger some detection on EDR, it might not be the end of the world. Like I've seen like countless cases where we did trigger alerts, and in some cases very specific alerts like Cobalt Strike alerts being closed as false positive just because the layer 1 analyst just had no idea how to triage that, or just couldn't be bothered. I don't know, something like that. But that's the reality, right? So for the rest of the presentation, we're going to use Elastic Defend, and not because I have anything against it specifically, but they're really good at the fact that they're publishing all the detection rules. So hopefully we're going to use some of them as some sort of, training ground to get an understanding on how the detection was built initially. Maybe we can find some flows and things like that. Also, it is like you have a 14 days trial for that. So I highly encourage to download that and give it a go. So a few metrics that we're going to use for this presentation. These are going to be useful to understand what is a bypass, what's an evasion, and stuff like that. So obviously, really simple telemetry is being able to collect specific events, right? Like, do you see like notepad.exe being run on an endpoint or stuff like that? Detection, as said earlier, is the aggregation of telemetry sources, different telemetry sources sometimes, just to capture malicious behavior, like a user John Doe run Mimikatz.exe, whatever on their endpoint. Prevention, again, I don't need to explain prevention, it's just stopping the attack from happening, a specific action in particular. But the interesting point is the investigation, right? Investigation is when an analyst actually takes in charge of an alert, let's say, and they start doing some triaging and stuff like that. Why is this important? Because a detection on its own it's not useful, just a message, just a ticket on whatever platform, it might be an email or something. It doesn't mean that someone will actively do anything with that. And the reason is that, these platforms, they tend to generate like thousands of detections. And so it's not reasonable for, a human analyst to analyze every single detection that comes from these platforms, right? So, usually they have some sort of threshold. Let's say if you have a critical alert, or if you have X number of medium or high alerts on a specific host, then, a ticket might get opened and an analyst will look into that. It doesn't mean that, alerts will just stay untriaged. It's just that, they have a pipeline of things to work on when I'm talking about SOC analysts, and so they cannot just analyze everything as it comes in. But they need some sort of way to navigate that mess of detections. So bear that in mind. And so let's get to the core of this. Like, what's an EDR evasion? Like, what am I talking about? And so, like, it is a bit confusing, and a lot of people in the industry are not too certain about what this actually means, right? And so, like, there was a Twitter poll as well that was done a while ago, trying to, gauge what the audience was thinking. And, you see the answer, like, most of them, alerts not generated, but even the rest, it means that there is a fair bit of confusion. Now, for the rest of the presentation, what is our definition of EDR bypasses? No automatic alerts will get generated. So we're not going to talk about response necessarily. We don't care about that now. Just mean that, if no alerts are generated, we're fine. What I mean by fine is not necessarily that we're going to win on our red team operation. That's not true. Simply by the fact that, even if you don't generate any alerts on a specific EDR that you're working against, it doesn't mean that, maybe a threat hunter will just check your activity at a later point, things like that. The thing is, if you do not generate alerts, at least in our opinion, your chances of not getting detected throughout the rest of the operation will be much higher. So no alerts, good thing. It doesn't mean that if you don't generate alerts, you're gonna, necessarily succeed in your operation. It doesn't mean that if you do generate alerts, you're gonna get eradicated pretty immediately. And another point is, what we mostly see when people discussing bypasses is they just care about shellcode loading. Like, if you have worked with, frameworks like Metasploit, Cobalt, right, blah, 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 that people, like, they do like to think that EDR evasion is just loading the shellcode. You see that, you maybe get a beacon or something, I bypass CrowdStrike, and you don't do anything else. And that's just not reality, right? You need to think that red team operations, they, you have to take certain steps to reach your goals, and not everything is on the initial access side. You need to move laterally, you need to extract credentials. So all the things that we're going to talk about, you need to be mindful of them throughout the rest of the presentation. If you just get a beacon running on an endpoint, good for you. But yeah, there is definitely more to that. So when it comes to the different types of evasion and bypasses, we like to use the framework that was created originally by SpectreOps, right? Now, this is not the complete framework. They had more bypasses, to be honest, but like they were not fully applicable to our cases, and maybe some of them would just never use them, so it wasn't really worth talking about them. What we hope to do is to bring some like gaps from the very theoretical concepts of these frameworks and show some practical examples as well. So we're going to start with the first one, which is the perceptual bypass. Simply put, it's just the sensor inability to collect certain type of event, right? The idea is that if you cannot collect specific telemetry, how can you detect that? Let's see. So let's have this like hypothetical scenario, right? we've compromised the box and we want to establish persistence on it. Of course, we want to maximize our chances of not getting detected, right? Because that's just obvious. So our hypothesis is, if we find a specific action to establish persistence that the EDR is just not able to log, that might increase our chances of not getting detected. So to do that, we're going to pivot to the EDR telemetry project, which essentially just a collection of all the major EDR providers with all the different type of telemetry they collect. So again, it's on GitHub. You can just access it. And we know in this case we're dealing with Elastic, so it's pretty easy to see what kind of things Elastic doesn't collect by default, right? And one thing that I forgot to mention before is that of course Elastic they do publish the rules, so we have an advantage in this case, right? But the thing is that all the concepts and everything that we're gonna explain, they will be applicable to situations where you don't have access to the rules that the black box product, whatever, is using. So in this specific case, we see that the local account creation doesn't get logged natively by Elastic. So you see that there is a log icon. I don't know if you can see that. What that means is that it can be collected, but it needs to be enabled by the native Windows event log. So it's not an out-of-the-box configuration that is present on the agent. So okay, good. Like we can use that as some sort of persistence. Very common. Like all the ransomware actors, they love creating local accounts and stuff like that. So we just hop on our testing box, and with anything, to be honest, like we're going to use like Atomic Red Team for this. We're going to execute a very simple test case to create a local account. So executing that and validate our hypothesis of whether that did trigger detections or not. So we execute the thing and we do actually get detected. So why is that? Like, are you lying to us? Not really, not really. So as I said, like the big advantage of Elastic is that we can inspect the rule that triggered and look at the specific definition of the rule. So you see that it did trigger on the execution of the classic net.exe binary with the /add. I know if you're doing like Red Team professionally, it's like, come on, what are you talking about, man? I know, right? But this is just an example to showcase a specific concept. So it's a very easy detections to implement, but like, yeah, okay, you said that there is no telemetry for that. Why then this gets alerted upon? So to better analyze that, we're going to pivot to another framework. I know that a lot of people need a lot of external frameworks to study. But this time, this is the capability abstraction, and hopefully we're going to use that to better navigate what we're doing. As I remember, adding a local account as our chosen persistence mechanism. So what is capability abstraction? It is essentially a framework that allows you to decompose a specific capability, again, in this case, adding local accounts, on different layers of complexity until you reach, what's the base case for that event to happen. See in the image, there is the curb roasting action, and you see that you have different tools at the top, but then as you go lower to the capability abstraction framework, you see what is the base condition for curb roasting to happen, which in that case is a network request for curb roast and stuff. So what we're going to do now is translate that to our specific case and try to see if we can rebuild the capability abstraction matrix for our own specific case. So, I mean, guys, I'm not a reverse engineer. I don't know how to do that. I don't even like that, to be honest. But it is pretty simple to go from the initial implementation of, what Atomic Red Team was using, so using net.exe, to understand what kind of API it was using to do that, and just continue dig deeper until we believe we reach the base condition for a user to be added to a system. So again, like you can use strings, you can use whatever, but essentially what you're going to find is that the net.exe is using just net user add, right? So a first step of evasion could be, okay, can we go a step lower? So instead of just using net.exe directly, we used the Windows API. It's possible, but Windows API can get hooked and things like that, and we don't necessarily want to deal with hooks and all those kind of things now. So we can try and go a step lower. So What I like to do in those cases is to pivot using the ReactOS, which is some sort of, I believe, right, Windows open source implementation or something like that. I have no idea, to be honest. I just use it for like finding Windows APIs. But the thing is, if you can look at the net user add implementation and see, what's the underlying API that is used, and if you do that, what you're going to find is that eventually those APIs are going to use the the Security Account Manager Remote Protocol, right? So it's RPC protocol that you can use. Documentation from Microsoft is a bit confusing, is an understatement. It's like 200 pages of PDF. But, if you spend, 5-10 minutes on it, you'll see that eventually you can find what's the exact API function that gets called by RPC, right? So again, you see that it's not too complex. From net2DXC, Windows API, RPC call. So the idea is that, the Elastic Detection Engineer implemented the detection at a really high level of the capability abstraction framework. And it's not a mistake, right? It's just, it's a really simple detection that can catch a lot of, malicious activity. It's also, always a trade between false positive or not. But, from us, like the attacker perspective, if we do manage to go lower, then hopefully we're going to increase our chances of success. Specifically, what we're doing now is to use, I don't even maybe I wasn't even bored when RPC client was coded initially, but you can use those kind of utilities, because just the first thing that come to my mind, just to create a local user on a machine, just using the RPC protocol. And, there's no surprise if you do that, there are no detection from Elastic, simply because it doesn't get logged. So how can you build detection on something that doesn't get logged? I don't know. If you know, let's speak later. But yeah, again, it doesn't necessarily mean that all the hope is lost, right? Of course, you can enable, the whatever advanced auditing is on Windows to get events whenever you create new accounts, and that will get logged by Elastic. But that's not, an out-of-the-box configuration. You need to enable those logs manually. And from an attacker perspective, you can check if a system has these logs enabled. So okay, they log user account creation and things like that. But if they don't, and that the product is, for example, Elastic or whatever other, you can, be almost confident that those specific actions will not trigger a detection if these are the only product in use. So what is this for saying? Again, initially we started from Atomic Red Team with a micro ID. If you're doing an assessment and you're relying on these micro IDs to get coverage, you're going to have a bad time, because these are not really too useful on these specific cases. The procedural differences from one attack to the other, even if they have the same attack ID, is immense. And also it means that all these products in general, they're not silver bullets, right? They have flaws. You need to configure them properly. And also, another thing that I wanted to mention, I've mentioned on the specific endpoint, but think of different OS versions or different, version of the same operating system. I know that a lot of process injection detection nowadays are based on the threat intelligence ETW providers, right? Which is really robust and really awesome. But if you land on a Windows 7 box, or if you do find a Windows 7 box on the network and you jump there, that ETW provider is just not existent, because, it's not supported. So in general, finding places where telemetry is not available on Linux systems, Solaris, those kind of stuff, is where a lot of attackers are moving to nowadays. So yeah, it's definitely an interesting one to think about. Now, the logical bypasses, again, this is a bit tricky, right? This is finding flaws within the implementation logic of a specific detection rule. And this is complex, right? Because maybe in some cases you don't have access to the actual rule that people wrote, because it's just, a kind of a black box product. In the case of Elastic, again, it's a bit simpler, but the fact that we're using Elastic gives us insights on what other detection engineer might think that a good detection is, right? So in this case, we're going to talk about creation of scheduled tasks by low reputation processes. Again, you see there that the rule is, it is quite simple if you used to read whatever Elastic writes. But, there is a process creation event from an unsigned process. And then you see that there is, in bold, you see that there is a file creation on the Windows task, the classic directory associated with scheduled task, right? So what can we say about this? Well, we can say that the detection engineering during the rule creation process, they identified a base condition, right? And the base condition in that case was if a scheduled task gets created, then the following file creation event will also be present. So a file created on the system32 tasks directory. That's an assumption, right? It doesn't necessarily mean that it's true. In fact, what we found on our research is that you can create scheduled tasks simply by modifying the registry, right? You don't really need to create files or go via the classic Windows APIs. You can just add some registry keys and you can create scheduled tasks. So you see that there was a flaw in that logic because they identified the base condition, but that base condition was not true, or at least it doesn't cover all the different cases that you might face. And again, this is like, it wasn't easy because this requires a level of understanding of Windows internals, reversing, experimenting, and things like that. This was actually done after a specific malware family. They were hiding scheduled tasks using some like registry keys, like changing the security descriptor of the scheduled task, and it wasn't appearing anymore on the GUI. So we took that a bit further, and we managed to create scheduled tasks without generating Windows event log and without going via the classic Windows APIs. So again, as I said, it is definitely a bit more complex, but you can find those different attacks and like, what kind of base condition people might see as, Windows service creation. Maybe some registry keys can be used, maybe some other keys can be used to achieve the same. I don't know, I've done mine on scheduled task, give me a break. But yeah, it's definitely an interesting one. And next one, I'm going to hand it to David for the other types of bypasses.
Thank you, Riccardo. So, configuration bypass. This, guys, is just a quick slide for us. It's basically because, as an attacker, you don't have like capabilities or visibilities around the configuration that is done on the backend. Most of the time, the solution has a management tenant that is in the cloud, and only the client and the security engineers or security operations center has access to. Basically, might be that the sensor is not configured to actually capture determinate events in this case, or on some legacy systems we don't have some capabilities, so we can't collect data. But also depends, and it's like, let's say we are a security engineer, we are installing the solution, we are configuring in the tenant the switches, and we might miss something, okay? Or let's say we have a specific critical system and we try to actually enable features, but there's a feature that would slow the system down. So basically, we're going to disable it, but an attacker might use it at his own advantage. Also, EDRs, are not plug and play. They require amount of configuration and timing, so they are prone to mistakes by the engineers in this case. There is an interesting project here, which is time exception, which shows basically that you can write a specific file on the folder you want to, and you monitor the timing of the file write, okay? So if some file takes more time than the other, probably is going to be scanned by the scanner. If the other one is faster, maybe you are in a whitelisted folder, okay? So probably on your post-exploitation phase, you can just drop your file on disk. Even like if you desire to drop a file on disk, it's better stay in fileless. But in this case, might be interesting and also to consider. Classification bypasses, in this case, is basically the inability of a product to determine if an event is malicious or not. What does that mean? Let's say we are logging some specific data traffic, and we have too much data in this case. So it's not reliable to create a detection upon it. So we cannot alone, using the specific event, determine that something is malicious. We might work around on IOCs, but in this case it's harder, okay? And often it is implemented as a filter for like false positive rates in this case. But we have an example here with an elastic rule, which is the unusual Windows native process performing LDAP activity. Here we have the rule. Basically, what the rule does is checks the execution, the start of a process that belongs to System 32 or SysWow 64 in this case, checks a whitelisted set of processes that are not taken under scrutiny, and also checks if the activity that is being performed loads a specific system directory services DLL, so a module that allows an attacker to actually interact with the environment, like for Kerberos hosting, like an example that we will see later, or LDAP queries in general. So for trigger this specific rule, it's fairly easy. What we did was we used Liver as a C2 framework. Well, we can use whatever framework we like to, C2 framework. We will execute the built-in Rubius Kerberos capabilities, Kerberos hosting capabilities. And this is actually enough to like cause some bells to ring, okay? If we check what happens behind the scenes, basically we execute Rubius in this case, and it will spawn a new process, which is, in this case, is notepad.exe, which is in the DNI list. So we are going actually to make something triggered, also because we are loading inside the process the DLL that we said before. This technique is fork and run, and we get detected. A quick win to defend from this would be just remaining in the context of our current process, okay? Like executing a beacon object file or remaining inside the process, pulling a thread and doing our stuff. Almost zero effort. But we have a problem here. The problem is that imagine you just had your initial access succeeding on a machine, and we have this process that has been seen for the first time, and it is both calling home your team server, so doing HTTP and HTTP requests, and also executing some LDAP queries or post-exploitation abilities that works around LDAP in this case. It's not the best idea. Let's say we can do better. So the question is, are we really blending in? Here is an example that we, Riccardo, take under consideration. Basically, we took a couple of big corporates and we started querying it using Sentinel in this case for specific processes, looking for processes that does LDAP queries, okay? The idea behind this is injecting into the process or using this process that already does LDAP queries or, let's say, LDAP traffic and blend in with it, okay? In this case, we chose MMC. MMC was also on the whitelisted binaries in the previous rule, but again, choosing a process that normally executes LDAP queries allows us, as we said before, to bypass this specific rule. Obviously, one thing here is we are using fork and run. It's a tradecraft that was really effective like some years ago. Right now it's easier to catch this technique, but this is just an example. We want to give you an idea of what happens, and when you blend in, even if there are other rules that detect execute assembly, we can still proceed and not trigger the rule. So ideally, if we do this specific, we follow this specific framework, this specific methodology, we can actually discard one by one the rules and bypass them, hopefully. So again, even if there are no alerts, Elastic generates some telemetry. Okay, so if you are a detection engineer, you can run and try to at least make a rule or work around it. Okay. Another example might be, let's have a context for this case. We want to do some PKI reconnaissance. So actually, let's say we compromised a target and we want to see if we can have a quick win with like ADCS, all the templates, all the vulnerabilities, common research, very famous, that came up a couple of years ago. We can say and choose a specific process. In this case, it's dust-cost-w. But again, we apply the same methodology. So we check processes that perform actually queries through the PKI infrastructure and blend in with it. So perform our post-exploitation inside this context. Okay. The question is this really OPSEC safe? Well, of course, it depends. It depends on the environments and many other variables. EDRs are complex products, okay? So we don't know most of the times because we are lucky in this case that Elastic publishes some rules. But again, thinking about other products, they are like a closed box, a black box. So we have no idea. But anyway, this process of course, was straightforward for this, but this principle that we described before can be applied, and you can conduct a better operation. Okay. So that's it for the classification bypass. So it's most about blending in. Okay. Going ahead, talking about tampering. Tampering is something that you can consider, but remember, it's risky. You know, it's risky. If you can't evade a defense, you can try to turn them off. There have been, like, I think months ago or a year ago, a threat actor that was actually selling this specific vulnerable driver with a tool with it that allows to kill some EDR solutions, like even bypassing their anti-tampering mechanisms. But again, it's risky because you're loading a driver, you probably don't have much control over the kernel, and it's easy to blue screen the machine or make mistakes and lose the access. If you can turn them off, you can just try and compromise their ability to report alerts. An example here might be using firewall APIs of Windows in order to fence the communication between the agent and the tenant, okay, and trying to stop the alerting mechanism. Point is that nowadays most modern EDRs has a way to alert you if the agent communication with the tenant is not happening. So this is something to consider during your operation, actually. Product tampering requires administrative access, okay, and most of the times it requires you to do some system modification. So watch out and be careful when you modify the system, like registry keys, COM objects, etc. You can do some sensor tampering. In this case, it exists on userland because it's where we have more control. We can attack, for example, ATW with ATW bypasses, patching like some functions in memory, or API unhooking. This is something that is known, that have been around for years, but is still effective. We left you here some resources and some research that me and Riccardo conducted. We attacked a specific product, and basically we tried to attack it on multiple points, okay, just the communication between the tenant and the agent, trying to see if there were like some unprotected processes around it that we could exploit, and basically that's it. So again, the tampering part is risky, but might be considered, okay? I'll hand over the presentation now to Riccardo for the final considerations. Riccardo?
Thank you. One last bit on the tampering side. Of course, there is also the ethical aspect as well, because there is a lot of controversy of like, oh, if you disable a product, you're doing red team, right? And you disable a product, then you impede essentially clients' ability to detect actual attackers, right? That might happen at the same time. So a lot of people don't really love the idea and things like that. So it's not always our first choice, but it is nevertheless like a possibility and a threat that you should consider in your threat model. So lack of response, as we said initially, right? A security operations center, they're not just tools, right? They're just people and processes as well involved on it. So it might be that something goes wrong with the people or the process. Maybe the people cannot triage an alerts, or maybe the process that they apply is not sufficient to fully eradicate you. Like, this might sound almost obvious, but we've seen that so many times that, security operations center don't validate the response playbook or don't train properly the layer 1 analyst to actually respond to attacks. So see, there is a bit of irony in the modern SOC structure where you have, the classic 3 layers. So layer 1 are the people that are in charge of, picking up the alerts first and deciding whether that's false positive or not. But, they're also the less experienced analysts. So you're putting a lot of trust in the hands of people that might not have the same skills as the other more experienced analysts in the team. And usually what we see is a lot of the time alerts get misclassified as false positive. We've done like an adverse regulation recently where we had to do like a lockbit-esque payload for initial access, which was like a DLL side loading of a VMware binary or something. And in the threat report that was initially published by Sentinel-1, there was like the payload was launched via PowerShell, right? We didn't, because we didn't like PowerShell. And so we essentially double-clicked on the vulnerable binary and loaded our malicious DLL. The analyst, they were good in understanding, oh, that's maybe something not great, but they found the report online, said, oh, that was not launched using PowerShell, so that must be good then. Well, it wasn't good, but luckily, they were also very lucky that an analyst with more experience actually stepped in and say, no, guys, you need to check this again. So, of course, the fact that some alerts might get misclassified, it is a concrete possibility. Also, applying response procedures, it is really important, and it's also really important when you consider the fact that a lot of modern attacks are also cloud-based and using a lot of SaaS products. So we do have some stories, for example, we had compromised a user with the classic phishing, so we had their access token and everything, and we did register an application that has that had Google Drive write permissions over that person. So there was an application running with their consent that we actually added ourselves, right? So what did the SOC team when they got notified? They just reset the user password and just called it a day. But we still had access, and they were not super happy about that, actually. But, yeah. Thank God I was not honest. But yeah, no, that is another real concrete possibility. So just to close, again, we gave you a few different examples, and it might have looked a bit disjointed in oh, we're adding user, doing LDAP thing. It's just an example, right? So what our suggestion is, our thought process is, whenever you're doing a red team operation, think about all the steps that you're doing, but don't consider steps like, oh, I need to do process injection, I need to run blood down and stuff like that. Think more granularly. I need to do beaconing using HTTP. I need to do file operations, right? And so for each one of these operations, think can you avoid being logged somehow? And if you cannot avoid that, can you maybe blend in, or can you turn off some sensors and things like that? Always try to go to the deepest level possible of these attacks when you execute them. And whilst, as I said initially, we're using Elastic, so even in the LDAP case, yeah, we had the rule. We could see that mmc.exe was being whitelisted, but that's not the point, right? It's not the point of looking what the rule exactly says. It is mostly about finding what specific event looks like in a generic, non-customer specific environment, and then trying to blend in with those kind of things. So hopefully that was at least vaguely interesting for you. We've left some resources to continue studying with all these topics. And, if you have questions, you can stop us after this talk. But I think we have a few minutes left for questions if you have any. Thanks.
Thank you, guys.
One question.
I'm very sorry.
I was hoping for no questions, but I'm kidding. I'm kidding. Of course.
Back up to the Friends meeting where the PD and were.
Say again. Sorry.
Back up to the Friends meeting where the PD and were.
Yes.
I apologize profusely. I'm pretty brutally off with architectural routine layout. Could you explain floods to me in this context?
Usually, explaining memes is interesting.
FUD acronym. I know the meme.
No, so FUD is usually it's fully undetected, right? It's like an acronym that a lot of people they like to use. This tool is 100% food, whatever, right? It's it's undetected by every product, and so it is annoying. So sorry if that wasn't. No problem. Easy. Okay. GG.
Perfect. Thank you guys again for having us here.
Cool.